Hello learners, welcome to this course on Embedded System Design using Raspberry Pi 4 module. In this tutorial, I will be discussing about how to measure the object distance using an ultrasonic sensor HC-SR04 module. So the complete project and its simulation is available in this GitHub repository link which is given below. So ultrasonic sensor is a sensor which can be used to measure the distance of an object in front of it. So it is a non-contact proximity sensing element. It can measure the distance, object distance range in terms of 2 cm to 400 cm with an accuracy of about 3 mm. The measuring angle is going to be 15 degrees. And it requires a power supply of 5 volt with a working current of 15 milliamperes. So here we show a typical HC-SR04 module which has 4 terminals. So VCC and ground can be connected to a 5 volt supply. Then it has 2 pins, trigger and echo pin. This trigger pin will be connected to your microprocessor or microcontrollers, through which we will generate a 10 microsecond TTL pulse. So here we show a typical 10 microsecond TTL pulse generated with the help of your microprocessor or microcontroller. As soon as this pulse is given to your trigger input of the ultrasonic module, this ultrasonic module, what it does, it will generate 840 kilohertz sound waves. So this sound waves, so here we have a transmitter and a receiver in this module. So the sound waves propagates in the environment. When we have an object in front of it, this sound waves hits the object and gets reflected back on the receiver. So the total time of flight can be measured with the help of this module. So as soon as the 8 pulses with 40 kilohertz are being generated, the echo pin, what it does is it will turn to logic high. So it will make a transition from 0 to 1. So this echo pin will be high until a pulse returns back and reaches the receiver. So this point is where the pulse gets reflected and it is reaching your receiver. Until that time, the echo pin will be high. So when we calculate this time, with the help of this time, we can calculate the distance of an object. So the echo signal is a TTL pulse proportional to the distance range. So if you see this module, it includes a transmitter, receiver and also a control circuit. So let us see the basic principle of the sensor. So using the I/O of your microprocessor, trigger signal will be applied to the sensor module for at least 10 microseconds. Then the module automatically sends 840 kilohertz pulses and it detects whether there is a pulse signal back. Once the pulses are sent, the echo signal turns high. So the time of I output for echo I/O duration is the time of flight of the ultrasonic pulses, the transmission of the sound waves to the reception of the sound waves. So with the help of this time period, we can apply a simple formula to calculate the object distance, which is nothing but the high level time, echo pin high level time into velocity of sound. We already know that it is 340 meters per second. Since this time is for the transmitted wave from the transmitter to the object and then it is back to your module again. So it's a total time period. So we are going to calculate only the object distance, which will be half of this value. So we divide that value by 2. So with the help of this formula, we can calculate the test distance. As I said, the pin out of ultrasonic sensor, we have 4 pins. VCC, we connect it to a 5 volt supply. Ground, we connect it to a ground line. Trigger signal is an input pin and the echo pin will be your output pin. So here in this project, we are going to measure the ultrasonic distance measurement using this sensor. in Proteus 8.13 professional software, and the language of programming is going to be your Python. So here we take a Raspberry Pi 4 module and incorporate a ultrasonic sensor module, right, HC-SR04 module, and in order to have an object in front of this module, here in this simulation we will be using this test pin. So this test pin can be connected to a potentiometer. By varying this voltage, it is equivalent to that of varying the distance of an object in front of the module. So we connect a potentiometer and we can vary this voltage, which in turn represents the object in front of your module. And we are going to calculate the distance of the object and we are going to display it on this 7-segment display. So here we connect this 7-segment display with 4 digits. Out of this 4 digits, we are going to use only 3 digits. First 3 digits we are going to use. And we are going to measure the distance in terms of centimeter and we are going to display it. So 7-segment, we already know that we have 7 segments here in each digit. So A, B, C, D, E, F and G, right. So all these segments are connected to this 4, 17, 18, 27, 22, 23 and 24 GPIO lines of your Raspberry Pi. And this trigger signal of this ultrasonic sensor is connected to GPIO 5 and echo signal is connected to your GPIO 6. So here we use a voltage divider circuit because this echo signal will generate 5 volt. So for your Raspberry Pi, we have to give 3.3 volt as an input pin. So we use a voltage divider with a resistance of 1K and 2K, and we try to take the 3.3 volt and feed it as an input to your GPIO 6 pin. Now let us look at the programming part. So we import the necessary packages. So the first package which we are going to import is the GPIO package, and then time package for introducing the delay function. Then we are going to connect your trigger line of your ultrasonic module with GPIO 5 and echo pin to your GPIO 6. And the 7-segment pins, so A to G. So A is connected to 4, B is connected to 17. So like that, each pin, C is connected to 18, D is connected to 27, E is connected to 22, F is connected to 23 and G is connected to 24. And to select the modules, we use 3 lines. So the 4 digits are there. Out of that, we are going to use only 3 digits. So the first digit is connected to your 20, second digit is 26, third digit will be 21. So first we try to initialize the port lines. First we try to say we are going to use the IC pins. The IC which we use in our Raspberry Pi 4 is going to be BCM2711 IC. So we are going to say that we are going to make use of the IC pins for our programming part. Then the trigger line is configured as an output line and echo line is configured as an input line. Then we try to take the segment pins and make it as an output pin, and initial value it is set with 0. Same way, digit pins of your 7 segment also is set as an output pin and with the initial value of 0. Then we create an array segment map for representing each digits. So we have a digits 0 to 9. In order to get 0 in a 7 segment module, so here when I take the 7 segment A, B, C, D, E, F, G. So you can say that in order to get 0, what we require? We require a module to go, B, C, D, E and F to have a 0. So to have a 0, we put from A to F. All the segments are 1 except this G segment. So G segment will be in off state. Similarly, for each digit, we try to select the segments. For example, 1, I require only this B and C. So those two segments alone is active, all the other segments are not active. Similarly, we try to provide a map for the segment pins for each digit. In our application, we are going to use a common cathode type of segment. Then we write a function to measure the distance. For measuring the distance, first thing is we have to generate a trigger signal. So trigger signal of 10 microsecond. So for that we use a GPIO.output function. So trigger signal, first initially we are setting it to false, so it will be 0, and then we are going to make this trigger signal to be true, so it goes to high and it will be retained for a high for 10 microseconds. So this duration is going to be 10 microseconds. So this 10 microsecond is specified here, time dot sleep equal to 0.00001. So 10 microsecond pulse is generated, and then again it turns back to false. So as soon as we set this trigger value to be 10 microsecond, what the module will do, it will try to generate 8 pulses with 40 kilohertz frequency. Right? After generating this pulse, what will happen? The echo signal will turn to on. So what we are going to do, we are going to check whether the echo signal has turned on. Until it becomes on, I am going to remain in this while loop. Okay? If the echo signal is 0, I am going to remain here. Once it becomes 1, okay, once the echo signal is 1, what happens? We are going to take the time and push it onto your variable pulse underscore start. So our echo signal is going to have the starting time. Then I am going to be in 1 until we have a switch over from 1 to 0 transition. Right? So the until, for example, the echo signal, it goes to high and it remains high until a wave has been received by the module. Okay? So once the wave has been received, the echo signal will go to 0. Right? So we are going to be in this while loop until my echo signal is 1. Once the echo signal goes to 0, once there is a transition from high to low, which means the module has received the wave back. So we are going to stop the time and take the time duration. So we know the starting time and also we know the end time. From this we can calculate the duration of this pulse. So the pulse duration is calculated by pulse end minus pulse start. Then this pulse duration multiplied by 17150. So this is speed of your sound wave is 343 meters per second. So when we convert it into centimeters, it will be 34300 centimeter per second. So this is total round trip time. So but we want only half the distance, so it is divided by 2. So that is what it is given here, 34300 by 2 and multiplied by the total duration, pulse duration. So we will get the distance and we try to round off the distance and return that distance from this function. So that is how we measure the distance of an object using an ultrasonic sensor. So now we want to display this value in a 7-segment display. So for that we write a function called as display underscore number. So in this we give this distance. So this distance we are going to print it and see in centimeters, and we are going to convert this number in terms of a string with the right justification of 3, which means if the distance is 200 centimeter, we get something like this with the 3 digits. With the 3 digits we will try to get. So now what we have to do, we have to take the first digit, move it on to the first segment. Second digit, move it into the second 7 segment. Third digit, move it to the third 7 segment. That is what we are going to do. Right? So what we are going to do in a for loop, I am trying to put I equal to 0. We take a variable and check whether it is 0. Right? If it is 0, I am going to enable. So 3 segments are there. 3 7 segments are there. So this first segment will be selected when I have I equal to 0. Second segment will be selected when I equal to 1. Third segment will be selected when I equal to 3. Since it is a common cathode type of 7 segment, what we have to do, this digit pin should be given with 0, right? It will activate this segment. So what we do here, when I is equal to 0, GPIO.output, digit pin of 0 is said to be 0, other 2 digits are not active. Okay, only the first digit is active, other 2 are not. If I is equal to 1, what we do is second digit is active. So second digit becomes active. In case of I equal to 2, third digit becomes active. Okay, it will be third digit will become active. So once I have this I equal to 0, I am going to put the value for the 7 segments. Right. So that is done here. So here in this for loop, I am going to check whether j is equal to I, which means j is also 0. J and I both are 0, which means the first segment is selected. Now what we do, we try to take the segment map. For example, if the distance is 200, okay, so this is available in your str_num. So what I have to do, I have to take this 2, okay, so here str_num of 0. So 0 means first digit, right? So 2. So I am going to take the segment map. So what is the segment map? So segment map, we have already said that it depends upon 2. 2 means I have to get these segments to be active. Okay, so A, B, C is not there, D, E, F is not there, G. So for this segments alone, we will have 1. Okay, so 1, 1, C will be 0, D will be 1, E will be 1, F will be 0, G will be 1. So this segment value we are going to take. That is what we get from this function. Okay. Segment underscore map, get the corresponding pins, assign it to the segment pins. Then output this value, right? Output this value to the corresponding pins. So 2 gets displayed when I equal to 0. When we have j equal to I equal to 1, then the second digit, right? So second digit will be selected. Second digit will be selected again. So when I have a value 200, the second digit. So the second digit value gets obtained here. So here what we will get? You will get, to get a 0, I should have these segments to be active. A, B, C, D, E, F. Right. So we will get 1, 1, 1, 1, 1, 1, 0. Right. So this value gets mapped with the segment pins and it is set as an output. So like this, each digit we are going to pick and we are going to display it onto the segments. So that is how we display the distance value in a 7 segment module. Then we write a main function where our embedded system is going to run continuously. So measure the distance, then I am going to display this distance continuously for 50 times. Otherwise, for every measurement it might change. Okay, so in order to retain the value for some time, so we are going to display this distance value for 50 times. Then we call this main program here. Okay, so this is the programming part of measuring the distance of an object and displaying it onto the 7 segment module. So now let us look at the simulation part. We will go to the Proteus environment. So here we have created our circuit. We make use of a Raspberry Pi and we take a ultrasonic sensor module, get connected to your GPIO6. Echo pin is connected to GPIO6 trigger pin is connected to GPIO5. Then we take a 4-digit 7-segment display, but we are going to use only 3 digits, first 3 digits, 1, 2, 3 alone we are going to use, 4 is not connected. And each segment of a digit is being connected to 4, 17, 18, 27, 22, 23 and 24. So in order to have the object placed in front of us ultrasonic sensor module in this simulation, this module can be connected to your potentiometer. By varying this potentiometer value, we can represent the object as being at different distance before the module. And remember, this simulation will not be an accurate, okay, this is a module which is created by this engineeringprojects.com, right? So it may not be accurate, but when you try to connect it in a real-time environment with the actual module, it will try to give you the exact result. So once the circuit has been built, we can write the code. So whatever the code which I have explained, it is given here, right? So we try to initialize the pins, configure the pins, then create a segment map to represent each digit, then write a function to measure the distance and write a function to display the distance. Then we define a main program and we try to call the main program. Once the programming is done, compile it, then go to the schematic and try to run the program. So when we run the program, you can see the distance is being measured. When I try to vary the potentiometer, you can see that there will be a change in the measured distance, right? So like this we can measure the object distance using the ultrasonic sensor module. So in this tutorial, I talked about how to measure the object distance using HC-SR04 Ultrasonic Sensor using a Raspberry Pi 4 module. Thanks for watching. Please like and subscribe for more technical learning. The complete project code and simulation is available in this GitHub repository link given below. Thank you.